Hello everyone, it's a pleasure meeting you all in my mathematics class again. Today my topic of discussion is the geometric distribution. I will explain what is our geometric distribution followed by a problem, and it will tell you how to approach the problem, any problem in geometric distribution. You see that geometric distribution is a discrete distribution in the sense that it's a random variable that follows that takes finite number of values or countably infinite number of values, and it is being described as the chance of achieving success. I must say that some chance of achieving the first success in a series of trials. That is, I am interested in finding out the probability of the first success in a series of trials, and which order, and these trials follow the Bernoulli's trial. Bernoulli's trial in the sense that the trials are independent and that the outcome of the trials are only two. They are either success or failure, defective or non-defective, like that. So under these conditions, we are trying to find out the probability of a success, the first success in a series of trials. Such a random variable will be called as said to follow a geometric distribution, and is given by P of x is equal to R is equal to, that means R number of trials are taken, and this is equal to, you are giving this as P into R to the power of P into Q R to the power of P Q to the power of R minus 1. That means P is the success that you get, and it is being preceded by R minus 1 failures. That is R minus 1 failures, then the success comes last, and therefore you get that this P into Q or Q to the power of R minus 1. And here you see that the success comes preceded by R minus 1 failures. Okay, so this is the probability mass function. This is the probability mass function of a PM of a geometric distribution, where this P is a success and P is success, and SUCC is success, and Q is failure, and Q is equal to 1 minus P. So with this idea, let me start now. So I have given you an idea of what is a geometric distribution. Now I will explain how you derive the expectation, because if it is a random variable, we can always go for finding the expectation, that is the probabilistic average and also the variance of the distribution. Okay, now I will explain how this is found, and then we will come to the given problem, which is not that much difficult. Just a good understanding of the subject will make you to approach the problem with ease. Okay, now let me derive the expectation of the random variable x. So I write it here. Let x follow geometric distribution, then P of x is equal to R is equal to P into Q to the power of R minus 1, the probability mass function of the geometric distribution. We know that, say right here, we know that the expectation of x, the expectation of any random variable is given by, it is x into, say, P of x, x into P of x. I know that this x is a discrete random variable, it takes finite number of values. So this is where P of x is the probability mass function of the random variable. So this is equal to, it is x into, it is P into Q to the power of x minus 1. This P to the power of 1, x minus 1, you will get it as what? So the x, that is P into Q to the power of x minus 1. So I can write this as p has nothing to do with this. So if the x will take the value from 1 to infinity, it will take from 1 to infinity. Take this p outside, so there is no it does not involve any x. So you write this as x into q to the power of x minus 1. So you can get the value of e to the power of x in many ways, but I will teach you by the straightforward method that I am going to work out here. So this is p by q into, it is x into q to the power of x. So this is equal to, so I am taking this q to the power of minus 1 as 1 by q, and I am getting this answer. So this is nothing but what? P by q into, you give the value for x, it is 1 into q plus 2 into q square plus 3 into q cube dot up to goes infinity. That is p by q. Take this q outside, 1 plus 2q plus 3q square plus dot up to infinity. That is p, because q and q get cancelled. This is nothing but your 1 plus 2x plus 3x square plus 4x cube. This is nothing but 1 minus x to the power of minus 2. That is p by 1 minus q whole square. That is p by 1 minus q is p. So p square, that is equal to p. See, I have used here, since I write it here, since 1 minus x, see, 1 minus x to the power of minus 2 is equal to 1 plus 2x plus 3x square plus dot up to infinity. So I am using this idea here, so that I am getting this, what instead of x you have got here q. So 1 minus q to the power of minus 2, simplification I get. So what is the answer that I get here? So I write it here. So your e of x is equal to 1 by p. So this is what I get. So this is how I find the value of the expectation of the random variable x, which follows the geometric distribution. Now let me work out what is my variance. Okay. So what is variance? So you must know that if you take statistics, if you take, we talk about random variables there, and if it is a random variable, we can always talk about the various moments, in which case the moments are mean and variance are moments only, and therefore they play a very important role in statistics, or for that matter in mathematics as such. And so we try to find out these two factors, namely the mean. This is called your mean of the random variable x. And let us now find what is your, see, variance of x. I will find variance of the random variable x. This is written as sigma x squared. This is equal to e to the power of x squared minus the mean of this whole square. Call this as your 1. Now you know the value of this. So this is nothing but what? Your e of x squared minus 1 by p square, as e of x is equal to 1 by p. This is proved. This is what we have, 1 by x proved. Therefore, we have to find only the value of this. So instead of this, I will take this as my 1. Now, I'll write it here. Now, e of x squared is equal to, e of x squared is equal to, so I can write this e of x squared using this. It is e of x squared into p into, it is q to the power of, or minus, I will write it as x minus 1, because you see that this is the probability mass function of the geometric distribution. I cannot straight away find this. So what I will do here is x into x minus 1 into p into q to the power of x minus 1 plus, it is sigma of x into p into q to the power of x minus 1. See, here you see that e of x squared can be written as e of x minus x into x minus c, x minus 1 plus x. So this is equal to e into x minus 1 plus e of x. So using this idea, I am writing it here. So I am getting this particular result. So you see that this can be written as, this can be written as, so you can take this p outside and you can see this is nothing but your x varying from 1 to infinity, and this is, you get this as x into x minus 1 into q to the power of x. You can take this q to the power of x minus 1, also you can have it like this, plus this value is known, this is nothing but what? This value is nothing but your mean, this is nothing but your mean of x, this is your e of x. So I will write this as, now you put x is equal to, start giving the values, it will be 1, it will be 0. If you give 2, it will be nothing but what? It is 1 into 2 into q, plus 2 into 3 into q square, plus 3 into q cube dot dot dot, it goes up to infinity, plus 1 by p, because e of x is equal to 1 by p here. So this is nothing but, see, I will write it here, this is nothing but, I will write here, we know that 2 into 1 minus, see, 1 minus x to the power of minus 3 is equal to 1 into 2 plus 2 into 3 of x plus 3 into 4 of x squared plus dot 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 up to infinity. So we know that this result. You see that this follows. If I take this q outside, it is nothing but what? It is 1 into 2 plus 2 into 3 of q plus dot 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 up to infinity. This is plus 1 by p is that. So in this place, 1 into 2 plus 2 into 3, I am using this formula. You see that you have got what? This 2 into 1 minus x to the power minus 3 is equal to this. Using this idea here, what I will get here is that, so this 1 into 2, this will be equal to 2 into, you just see that, 2, this is 2 into, instead of x you have got what is your q. So it is nothing but 1 minus q to the power of minus 3. This is what it is. So this is nothing but what? 2pq divided by, I write here, this is plus 1 by p. So this is equal to 2pq divided by 1 minus q whole cube plus 1 by p. So this is equal to, you see, this is nothing but 2pq divided by 1 minus q is your p. So this is p square plus 1 by p, that is equal to 2q by p square plus 1 by p. So this is what I get for my e of x squared. So e of x squared value has been found. Now substitute this in 1. So substitute this in 1, you will get the answer. So what is that you will get? Therefore 1 becomes, I write here. Therefore 1 becomes, it is sigma of x squared is equal to, e of x squared is equal to what? 2q divided by p squared plus 1 by p minus, you see that this is equal to 1 minus 1 by p squared. Now as simplification will give you the answer. So I will rub off everything here. So what is that you get here now? So this is nothing but your 2q by p squared minus 1 by p squared. I will write this as p by p squared. So what is that we get here now? This is nothing but 2q by p squared minus 1 by p squared into 1 minus p. So this is nothing but 2q by p squared minus this q by p squared. So this is gives you q by p squared. So this is what. So what is your variance now? It is equal to q by p squared. So these are the two answers. So this is now the derivation of what? The mean and variance of a geometric distribution. So geometric distribution is nothing but It talks about the probability of getting the first success in a series of trials. Nothing more than that. Okay. Now, let me start doing this problem. Here in this problem, you see that just mere application of the ideas with some sort of logical reasoning will give you the answers. Now, we'll start doing the first one. Let me take the first one. Now, what is the first one we have got here? What is the first problem? So, you are asked, what is the probability that the first of the four women who are chosen? See, I'm sorry. Here you see that 25% of the women working in the outlet center have never been married. That is, there is an outlet center where 25% of the women are found not have married. Suppose we randomly select who are working in a outlet center. That is, randomly few people are chosen, and the questions that follow below that. What is the probability that the first of the four women who are chosen is not married? That means simply four women are chosen. You have to find out what is the probability of the first woman not married. See, that means here I write here. So X is a random variable of a woman not married. Here you see that four women are taken. What is the probability of the first woman to be not married? That means P of X is equal to 1. P of X is equal to 4 in the sense that there are 4 trials are conducted. 4 trials are conducted, and you have to find out what is the probability of a woman not married. So this is nothing but what? We have to find this. We know that X follows geometric distribution. X follows geometric distribution, and therefore P of X is equal to R is equal to P into Q to the power of 1 minus 1. P is success. That is, a woman not married. A woman not married, and Q is equal to 1 minus P, which is a woman married. You can take it as a failure. That means P is a success here. Success in the sense a woman not married. And Q is nothing but 1 minus P, and the woman is married, which you can take it to be a failure. Since this follows geometric distribution, we are finding the first woman who is not married. If P of X is equal to R is equal to P into Q to the power of 4 minus 1. Simply apply and substitute the values you will get. Now what is your P of X is equal to 4? So in the place of R you have got this. So what is the success here? P. So Q to the power of 4 minus 1, 3. That is P into Q to the power of 3. But P is given to be, your P is given to be 25%. That is equal to 0.5. Q is equal to 1 minus 0.25. That is equal to 0.75. So this is equal to 0.25 into 0.75 whole cubed. So that will give you the answer. I will just give you the answer because these are some workings that you can do by just using the calculator. You can just work it out. So you see that what answer you get here for this is, it is 0.0546. 0.0546. 0.10546. That is equal to 10.55%. That means if you take 4 women out, the chances of getting one woman not married is 10.55%. That is 0.10546 chances are that the first one will not be married in a selection of 4 women. That is the meaning of that. Now let us pause on to the next one. Let us pause on to the next one. See? So this is answer. So what is this? The probability of a woman not married in a selection of 4 women in the what? In the outlet center. Okay. Now let us pause on to the next one. What is the next one that is asked? The next one is, what is the probability that the first 4 women we choose are not married? So you choose, that means here it is like this. Since the trials are independent, you take one woman, see whether it's married or not. Second woman, 2 women, 3 women, 4 women there is. So this is P of x is equal to 1, because you must know that here the trials are independent, therefore the sum of the probabilities is equal to, the probability of a sum is equal to sum of the probabilities. So P of x is equal to 1 plus P of x is equal to 2 plus P of x is equal to 3 plus P of x is equal to 4. You must know that all these are geometric distributions, and that we know P of x is equal to r is equal to P into q to the power of r minus 1. P into q to the power of r minus 1, where r refers to what? The number of trials that are made. Okay, the number of trials are 0. So this is nothing but what? Applying this idea here. So this is nothing but what? Here it is P into q to the power of 0 plus P1 q1 plus P1 q2 plus P1 q3. That means this is a success. The next one is, because one failure, then the next comes. Here 2 failures, then the third person is unmarried woman. And here 3 are married and the fourth person is unmarried. Okay. So this is what we get. Now this is equal to what? So this can be written as, so this is 0.25. Here anything power 0 is 1 plus 0.25 into 0.75 plus 0.25 into 0.75 whole square plus 0.25 into 0.75 whole cube. This we have found. This time. So if you use the calculators and do, what that you will get here is, it is equal to 0.68359, that is equal to 68.35%. So what is the meaning of this? The probability of you taking 4 women. If it is also that mean, I am finding out what is the probability of the first 4 women we choose or not married. First 4 means you take the first woman and see whether it is married, and you take next, you take 2 women, and what is the probability of a woman not married. You take 3 women, what is the probability that one of them is not married, and 4 women. So if you calculate in that way, P of x is less than or equal to 4, then we see that this is 0.25 plus 0.25 into 0.7. This is P into Q0 if it is 1 woman. If it is 2 women, P into Q. If there are 3 women, you take this P to the power of 1 into Q, because 2 failures and then the success. And here it is 3 failures and then the success. These things happen if it is less than or equal to 4, and you get. That means the probability of the first 4 women we choose or not married is equal to 0.68359, or that is 68.35% chances that the 4 women that we choose are not married. Okay, then now let us come to the last one. What is the last one here? See, the last one is find the mean. What is that? They asked what is the expected number of women in the outlet who are not married. We know that E of x is equal to 1 by P. That is equal to what? 1 by P means 1 by, we have found what is that P is equal to what? 0.25 given. So 0.25, that is 100 by 25, that is equal to 4. So the expected number of women who are not married is equal to 4 in the outline. Also sigma of x square is equal to, what is the sigma of x square? It is q by p square, that is equal to 0.75 divided by 0.25 whole square, that is equal to 0.75 divided by 625. 1, 2, 3, 4. So you see that if you simplify this, your answer will be this is nothing but what, since this is not asked in the problem, I am not doing it. So you can go for calculation and do this, and therefore your standard deviation will be equal to sigma of x, that is nothing but your square root of 7.5 divided by 0.625. This is the answer. So this is all about the problem with this geometric distribution. I know that geometric distribution is a discrete random variable that follows a pattern like this. P is equal to, that is QC. This is the probability mass function. Where R is the number of trials that you take, out of which the first, what is the probability that you get the first to be a success, and the rest of them all will be failures. This is the probability mass function. And I explained, I have worked out how do you get this mean and also the variance, and I have worked out the problem, and this is also that. Then I will in the coming days I will take tougher problems and solve how I will explain how we can solve them. So okay, thank you.